Good evening, students. Are you able to hear me?
Yes, sir.
Good. So we'll get started with the next exercise. Just give me a minute. Yeah. So, is there any doubt from the topics that we discussed yesterday? Do you guys have any doubt from the topics that we discussed yesterday?
No, sir.
All are clear?
Yes, sir.
Okay, good. You think it's a problem? What's up? Okay. Sir, listen. So till now, we have been discussing the concepts related to direction, cosines, and the direction ratios. And we understood how those two parameters are related to each other. So if we recollect the concept, we know the direction cosines are basically cos of the angles made by the line with the respective axis. That is cos alpha, cos beta, and cos gamma, which in short form are represented as L, M, and N. In a similar way, what are direction ratios? Direction ratios are those numbers which are in proportion to the direction cosines that we have taken into consideration. Now, the important part is we learned these concepts of direction cosine and direction ratios to understand how to write the equations of certain shapes like a line and a plane, right? So when you talk about the equation of a line, the first thing that comes to our mind is ax plus by plus c is equal to 0. But we know that it has only two parameters, so that ax plus by plus c is equal to 0 is confined to two-dimensional plane. Now the question is, how do we extend the same concept to a three-dimensional space? And that is what our topic now is, equation of a line in a space, right? That is equation of a line in space, for which the first parameter that we need to write the equation of a line through or equation of a line in spaces, that is the equation of a line through a given point means if a point is given to us, along with that point, if we also know the line to which the equation, so the line to which the expected line is parallel. I repeat it again. So the topic is equation of a line through a given point and parallel to a given vector B. Meaning, we are given a point through which this line is going to pass. So let me call that point as A, right? And there is a vector B to which the expected line L is. So there is a line that is passing through. There is a line that is passing through the given point, and the name of the line is going to be L. Now, if you observe, this line L for which the equation is expected is parallel to another vector B. Now, using these two information that we have, how are we going to frame the equation of this particular line L in terms of the given point and the given vector? For which we need to think in terms of vectors, right? So what am I going to do is, on the line L, I will consider a point P, which is a general point, right? So that I am able to define the position vector of the 2 points that are lying on the line, that is A and P, as A vector and R vector. And remember, wherever they say the word given, it means it is a constant, means it is known to us, right? So here A is a constant, whereas R vector is a variable which can lie anywhere on this line, right? Now, having these 2 points, if I draw a separate diagram of O, A, and P, then I have OA vector given as A vector and OP vector given as P vector. Then I have AB vector, which I do not get. So it is not known. But one thing is clear to me, that by taking these 3 points, I can construct a triangle. And since I told you we are going to use the concept of vectors, we can use the triangle of addition of vectors. So the next job of ours is to find this AB. How to do that? For which if you look at the statement, they have already given they have already given a vector to which this line is parallel to. So I can say AP is a portion of the line which is parallel to B vector, right? So when it is going to be parallel to B vector, from the concept of vectors, we know that AB vector is going to be lambda times B vector, because that is a condition for parallelism between two vectors. If two vectors are parallel to each other, we know that one vector can be written as lambda times another vector. So AB vector is lambda times B vector, meaning lambda B vector. Our job is simple, right? A small correction is AB vector is R vector. Right? Now if you see, we have a triangle where the sides OA and AB are continuous. So I taken AB vector because B vector is in the rightward direction. So I considered AB vector. So I know the fact that OA vector and AB vector are continuous. So from triangle of addition, what can you say? OA vector plus AB vector will be equal to OB vector. So OA vector plus AB vector is equal to B vector, which implies A vector plus lambda times B vector is going to be equal to R vector, and this is going to be the equation of a line to a given point and the vector B bar parallel to it. So I hope it is clear. So I hope this is clear. Is there anyone who's not clear with this?
Sir,
Please tell me.
sir, what is A? Like, is it a arbitrary point on the line?
Point. So read the requirement clearly. Equation of a line. Which line are we trying to write? The line L. Right? And that line L is passing through whom? Through a given point. Means there is a point A which is known on that line. See, a line has infinite number of points, of which if we know one of the points, and if we know the vector to which this line is parallel, then you can write the equation in the form R vector is equal to A vector plus lambda times B vector. Am I
Sir,
clear?
but we also need P, right? The point P.
The point which we can consider, no, it is a locus point. It is a general point, no? P is some x comma
Okay,
y.
okay. Understood, sir.
Understood? Yeah. So R is the generic point. A is a given point, and lambda B is something we framed it from the parallelism concept from vectors. Okay. So make a note of this. I hope others are also clear, right? Is there anyone who's not clear, not satisfied with it?
Yes.
Clear?
Yes.
Okay. So please make a note. Let us see. Where the return copy? Let me know if you're done copying. Shall I proceed?
Yes, sir.
Yes, sir.
Yeah, yes. Now we saw how to write the equation for a line which is passing through a given point and parallel to a given vector in the vector form. The next point that we are supposed to see is how to write the same equation in terms of Cartesian, right? So the same equation of line in Cartesian form. So let us recollect all the parameters that they gave it first. So L is the line which is passing to point A, and B is some generic point that we consider, and there is another vector P to which this line is parallel. So let's think of the logic. So whenever they give a point, it can be taken as x1, y1, z1. That is the subscript that we use, x1, y1, z1. Similarly, when you take a generic point, you can take it as x comma, y comma, z. Now what I'm going to do is, I will consider p vector as, use up to the step, I will consider this p vector as a I cap plus b j cap plus p k cap. See, this is where I want you all to pay some attention. Listen. So there are places where we write the vectors using direction cosines, and there are places where we write the vectors using direction ratios. Here, one point I would like to stress upon this. When I wrote this B vector, I wrote it as AI cap plus BJ cap plus CK cap, where this A, B, and C represent the direction ratios of this line. Please make a note of this. And here, not to be confused, that is, don't confuse this A with the point A vector. No. Here I repeat it, AI cap plus BJ cap plus CK cap, the coefficients of I, J, and K, that is A, B, C are the direction ratios of B vector. So I'm writing it here. A comma, B comma, C are the direction ratios of B vector. This is a very important point to be right. So ABC are the direction ratios. Okay. Now, if I look at A vector, then it is going to be x1 I cap plus y1 j cap plus z1 k cap. So how can I write it? Because I know the position of this point A with respect to origin. So x1, y1, z1 are the coefficients of I cap, j cap, and k cap respectively. It's very simple, right? And it's simple. Position of R, that is B vector, then it is going to be xi cap plus yj cap plus zk cap. Now concentrate again. We have all the vectors in the standard form, right? That is R vector, A vector, and B vector. We will have it in the standard form. And we know that the vector equation of this line is going to be R vector is equal to A vector plus lambda times B vector. Right. So here, what is going to be the value of R vector? It is xi cap plus yj cap plus zk cap is going to be equal to a vector, that is x1 I cap plus y1 j cap plus z1 k cap plus lambda times ai cap plus bj cap plus ck cap. Now, if I collect the I cap terms on both the sides and compare them, then I'll be able to get the equation of the side. So for this, what I'm going to do is, I will take this vector to the left hand side. So I'll take this vector to the left hand side so that it becomes so when I take it to the left hand side, it becomes x minus x1 I cap plus y minus y1 k cap plus z minus z1 k cap is equal to the right hand side. We are left out with lambda into ai cap plus bj cap plus ck cap. So from this, what can we conclude? Since two vectors are equal, the corresponding coefficients of I, j, and k are supposed to be equal. So from this, I can say that x minus x1 is equal to lambda into a, and y minus y1 is equal to lambda into b, and z minus z1 is equal to lambda into c. I'll bring the a is to the denominators of the left hand side, so that we have x minus x1 divided by a is lambda, y minus y1 divided by b is lambda, and z minus z1 divided by c is also lambda. Since all the equations are lambda, we can say x minus x1 by a, y minus y1 by b, z minus z1 divided by c, and this is going to be the Cartesian form of the line. And here, I want you to note an important point. So this is the generic equation. But sometimes, instead of giving you the direction ratios of B vector, if they give you the direction cosines of B vector, then you can still write it down. So here you know, if direction ratios of B vector is known, then we can write x minus x1 divided by L is equal to y minus y divided by L is equal to z minus z1 divided by N, because we know that the direction ratios are exactly in proportion with the direction cosines, right? So here I'm stressing on the point again. By default, you should only write it in this format. So you need to first check whether they have given you the direction ratios or direction cosines of B vector. Depending on that, you will choose either of them. So I hope this is clear, right? Is it clear, guys?
Yes, sir.
Yes, sir.
So here, this is the important point, that is A, B, C are the direction ratios of B vector. Seriya? So A, B, C are the direction ratios of B vector, correct? That is an important point you need to note. See, actually speaking, this much of in detailed explanation I'm giving it only because if at all you forget this expression in the exam hall, you should be in a position to derive it. Okay. So let's look into the next slide. I hope you are copying it now. Is this okay? Guys, if you are clear, I'll proceed to the next part.
Yes, sir.
So there is an example problem given. Read the question. Find the vector and the Cartesian equations of a line through the point 5, 2, minus 4, which is parallel to the vector 3i cap, 2j cap, and minus 8 cap. So in page 469, we have example 6. The question is, find the vector and the Cartesian equation of the line passing through the point 5, 2, and minus 4. Right? So the point given is 5 minus 4. So this is going to be A, and it is parallel to the vector 3i cap plus j cap minus 8k cap. If you see, this is going to be D vector. Right? So when I have to write into the vector form, then we know that R vector is equal to A vector plus lambda times B vector. So R vector is equal to, what is A vector? It is going to be 5i cap plus 2j cap minus 4k cap. So simple. Take these values, add I cap, j cap, and k cap, and write it in this form. Plus lambda times B vector is 3i cap plus 2k cap minus 8k cap. Right. So this is going to be the vector. Okay. And for Cartesian form, we know that x minus x1 divided by a is equal to y minus y1 divided by a. So as I've been stressing on one point, when you write it the Cartesian form, we know that there are two equations possible. That is x minus x1 by a is possible, y minus y1 by b is possible, or z, and z minus z1 by c, or x minus x1 by l is equal to y minus y1 by n, or z minus z1 by n is also possible. When these two scenarios are going to be there, how would you find whether they are given you the direction ratio or direction difference? This is where I would like to stress on one important point. If they give it in the vector form, right, it is going to be direction ratios. Whereas if they give it in the form of a unit vector, that is, if they give it as b cap, then the coefficients of I, j, and k represent the direction cosines. So here, if you see, when you do the square root of, that is when you find the magnitude of b cap, what are you going to get? You're going to get root of 9 plus 4 plus 64, which is a value greater than 1. And what is the relation we know between direction cosines? L square plus m square plus n square should be equal to 1. When it is not equal to 1, obviously the numbers that are there are going to represent only the direction ratios. So in this problem, this 3 by minus 8 represent the direction ratio. So answer is going to be x minus 5 divided by d is equal to y minus divided by is equal to z plus 4 divided by minus 8. because A is 3, B is 2, and C is -8. So I hope this point is clear. Right? So make a note. If you have any doubt, ask. So if you're done with this, I'll proceed to the next step.
Sir.
Ah,
I have a doubt.
hmm.
Sir, even if it was direction cosines, the equation would be same, right?
I'm saying they cannot be direction cosines. They cannot be. They either have to be a direction ratio or a direction cosine. I tried to explain to you when will it be direction cosine and direction ratio. In this case, it is direction ratio or cosine.
So ratios.
Ratio because 3, 2, and -8 are in such a way that 3 square plus 2 square plus 8 square is not giving you a 1. If it gives you out 1, then it is going to be direction cosine. Why I'm stressing is, had they given you direction cosine, then you should have not written this formula. You should have written x1 by L.
Yes, sir. Sir, but the equation in the end would be the same, right?
The equation will be this.
Okay, sir.
Shall I proceed?
Yes, sir.
The next concept that you're going to see is equation of a line passing through two given points. So this is a case where instead of giving you 1 point and 1 vector to which the line is parallel to, what they have done is they've given you 2 points through which this line is passing. Okay. So let me show you a diagram. Suppose I have a line L for which I am expected to write the equation. Now, one of the points to which the line is passing is x1, y1, z1. And another point to which this line is passing is b, x2, y2, z2. So from the origin, if I consider the position vector of A as A vector and the position vector of B as B vector. Right, if I take the B vector, then our job is to write the equation of this line, for which the logic is again simple, right? We need to consider a generic point on it. And let me call the point P, x comma y comma z, where I take this OP vector as R vector, right? Now, if I take the triangle O, A, and B, right? If I take the triangle O, A, and B, I call this as A vector, this is R vector, right? Where OA vector is A vector, AB vector, I don't know, and OP vector is R vector. Now, what I'll do is I'll consider the line segment AB. So when I consider the line segment AB. Right? So A has the position vector A bar and B has the position vector B bar. Then what is AB vector going to be? So what is AB vector going to be? It is going to be final position vector minus initial position vector. That is B vector minus A vector. Right? Now observe, AB vector is a part of AB vector. So AB vector is a part of AB vector. When AB vector is B vector minus A vector, then AB vector will be some lambda times B vector minus A vector. Because that is what the condition for collinearity of vectors tells us. That is AB vector some lambda times AB vector because A, B and B are collinear with respect to each other. Right? They are collinear. When this is the case, I got the triangle OAB for which I am going to apply the triangle of addition of vectors. This is the answer as OA vector plus AB vector is equal to OB vector. What is OA vector? A vector plus AB vector is lambda times B vector minus A vector is equal to OB vector, which is R vector. So R vector being equal to A vector plus lambda times B vector minus A vector is going to be the equation of the time in vector form, which is passing through the two given points A vector and B vector. So I hope this is clear. Is it clear? Is it clear, guys?
Yes, sir.
Make a note of it. So if you're done with this, I'll go for the Cartesian form. Shall I? Shall I proceed?
Yes, sir.
Yes, sir.
So we have seen that the vector form is R vector is equal to A vector plus lambda times B vector minus A vector. Extending the same concept to Cartesian form. Let's see how to write the Cartesian form of the line given points. So if I take A to be x1, y1, z1, B to be x comma y comma z, and B to be a point x2 comma y comma z2. Then the equation of the line which is passed through all these 3 points is going to be R vector is equal to A vector plus lambda times B vector minus. But what is going to be R vector R vector is xi cap plus yj cap plus za cap is equal to what is A vector? A vector is x1 I cap plus y1 j cap plus z1 k cap plus lambda into what is going to be B vector minus A vector? It will be x2 minus x1 I cap plus y2 minus y1 a cap plus z2 minus z1 k cap. Right. Now I will take this vector to the left hand side, then I'll get x minus x1 times I cap plus y minus y1 times j cap plus z minus z1 times k cap is equal to lambda into x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now, if I rearrange the equation, I get x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 z minus z1 divided by z2 minus z1 is equal to lambda. Why is it so? Because when I compare the coefficients, it is similar to the previous derivation. X minus x1 is equal to lambda times x2 minus x1. So I'm bringing the x2 minus x1 here. Lambda is left out on the right hand side. Similarly, y minus y1 is equal to, I'll bring this y2 minus y1 to the left hand side. Lambda is left on the right hand side. Similarly, z minus z1 by z2 minus z1. So if you observe everything, then this particular expression or equation, right? This particular equation is going to be the equation of line 2 points in Cartesian form. So this is all about the equation of a line in the Cartesian form. Am I clear? So if you compare both and see, no? Yesterday, when we know that the equation of line through, when we know 2 points x1 x1 y1 z1 and x2 y2 z2, you know how to find the direction ratio of that line, right? How do we do that? How do we find the direction ratios? You will simply find the difference between the x coordinates, difference between the y coordinates, and the difference between the z coordinates, correct? So if you observe, is this equation not similar to the previous one that we saw? X minus x1 by a, instead of a, you know that, you know 2 points, that is why you wrote x2 minus x1. Similarly, y minus y1, you know the other 2 points, that is why you wrote it as y2 minus y1. So z minus z1 by, you replace the c with z2 minus z1. Am I clear with that?
Yes, sir.
Yes, sir.
So if you see, they both are actually the same equation in different forms. So don't confuse yourself thinking that there are multiple equations to be remembered, nothing. The logic is very simple. R vector is equal to A vector plus lambda times B vector. That is a generic equation, right? So depending on whatever the data they have given you in the problem, you need to proceed with that particular values. Okay. So with this, we are ready to solve the problem. Shall we get started with the problems? Okay. So let's get started. So can you tell me what the next example will be? If you look at example number 7, what is the find the vector equation of y passing to the point A minus 1 0 and B 3 4 6. Right? So what is the equation? What is the equation of the vector equation? So R vector is equal to A vector plus lambda times B vector, which implies R vector is equal to what is A vector? Minus n cap plus 0 j cap plus 2 k cap plus lambda into T I cap plus 4 j cap plus 6 k. Okay. So this is the equation.
Sir, lambda into B vector minus A vector, no, sir.
Right. Yeah.
2 points.
How much are we getting? Lambda into B vector minus B vector. So you will get 4 I cap plus 4 j cap plus 4 k cap. Right? So this will be the equation. Okay. Did they ask the Cartesian form or not? Okay. I think problems are simple, right? So I hope the problems are simple. This is how you will have nothing so complicated, but only thing is you should understand why those equations are. So lambda is 2 b vector minus. So the Cartesian equation of the line is what is that? After saying therefore the question for you. And over it is not clear. So example 8, what is the question? What is the equation they are given? X minus of respect. So what is the Cartesian equation of the line that they have given? Can someone read it? X
x plus 3 by 2
x plus 3 by 2 are there. Okay, x plus 3 by 2.
equal to y minus 5 by 4
Y minus 5 by 4 is equal
is z plus 6 by 2.
to. Okay. So they are given this as the Cartesian form. Now you need to find the vector form. Will you be able to do it? It's very simple. So we assume this will be lambda. X will be equal to 2 lambda minus 3. Y will be equal to 4 lambda.
Sir,
Then
sir, in this question, how would we know that the denominator is direction ratio or cosine?
square and add them. 2 square plus 4 square plus 2 square.
Okay, sir.
See, mostly what will happen, direction cosines will be in terms of fractions. Right? That's the logic. So x is equal to 2 lambda minus 3, 4 lambda plus 5, and 2 lambda minus 6. What is the equation? R vector is equal to xi cap plus yj cap plus zk cap. Right? That is the basic expression for R. R vector is xi cap plus yj cap plus zk cap. In the place of x, substitute 2 lambda minus 3. So 2 lambda minus 3 I cap plus 4 lambda plus 5 j cap plus 2 lambda minus 6 k cap. Now separate the terms as minus k cap plus 5 j cap minus 6 k cap plus 2 lambda or lambda into plus lambda into 2 I cap plus 4 j cap plus 2 k. Did you understand what I did? I just separated the terms. Simple, right? Will you proceed? So So the next concept that we are going to see is angle between two lines. Simple. See, everything you need to do with respect to the chapter, recollect the concept of vectors. So angle between two lines, if I give you two vectors, A vector and B vector, then how you find the angle between them? Can you tell me the formula that we use? Cos theta will be equal to A vector dot B vector by magnitude of A vector and magnitude of B vector. Right? So similarly, let us say if one of the lines is given as R vector is equal to A1 vector plus lambda times B1 vector, and the second line R vector is given as A2 vector plus lambda times B2 vector. See, it's very simple. Like for a two-dimensional geometry, how AX plus BY plus C is the general equation of a line. In vector form, right, in three-dimensional space, the general form of a line in vector form is R is equal to A plus lambda b. I wrote it as A1 and A2 because A1 is a point on line 1 and B1 is a vector to which the first line is parallel to. Similarly, R vector is equal to A2 vector plus lambda times B2 vector. A2 is a point on the second line and B2 is a vector to which the second line is parallel. So, if I take this as B1 vector and if I take this as B2 vector, then can I say that the angle between the lines, I repeat it, listen to this carefully. Can I say that the angle between L1 and L2 is same as the angle between B1 vector and B2 vector? Can I say that? Guys, are you able to understand what I'm trying to say?
Sir?
L1 is parallel to B1. L2 is parallel to B2. So what is the topic? Angle between two lines. So if I need to find the angle between two lines, can I find the angle between those parallel vectors to which these lines are lying? Can I say
Yes.
that? Yeah. So angle between L1 and L2 is the same as angle between B1 vector and B2 vector. So cos theta will be equal to how much? B1 vector plus B2, B1 vector dot B2 vector by magnitude of B1 vector into magnitude of B2 vector. That's right. So if you're simply going to do the dot product between both, you're going to get the answer. That's okay. Listen to this. So whenever they ask you the angle between length, mostly will measure only the acute angle. You're not going to take the obtuse angle. That is why you see you can activate the modulus. Okay. Now listen to this. If they're given in the vector form, okay, we'll find it like this. What if they have given you the Cartesian? That is the first line. Similarly, x minus x1 by a2 is equal to x minus x2 by a2 is equal to y minus y2 is equal to z minus z2 by c. Then cos theta will be equal to, listen to this, it will be a1 a2 plus b1 b2 plus c1 c2 the whole divided by root of a1 square plus b1 square plus c2 square. Okay, is it clear? Now you say. If I see the example 9, then R vector is given as P I cap plus 2K cap minus 2K cap plus lambda times I cap plus 2K cap plus 2K. Okay, similarly, the second equation is given as R vector is equal to 5 I cap minus 2K cap plus some new time D I cap plus 2J cap plus K cap. Now I need to find the angle between these two lines. So how do I do that? Cos theta will be equal to B1 vector dot B2 vector by magnitude of B1 vector into magnitude of B2 vector. So when I do this is B1 vector, this is B2 vector. So what is B1 dot B2? I'm going to get 3 plus 4 plus 12. The whole divided by square root of B1 square is 1 plus 4 plus 4 into root of B2 square will be 9 plus 4 plus 36. So take the modulus here. So 12 is 16. So 90 divided by 3 into 7. So it will be 90 by 21. So what is cos theta? So theta will be equal to cos inverse of 90 degree. Then the answer? Cos inverse of 90 divided by 21.
Sir,
Tell me.
sir, in the left hand side, like in the general equation, sir.
Hmm.
Yeah, so in that A1, A2, B1, B2 are those coefficient of,
They are the coefficients of B vector.
okay, sir.
So they are the direction ratios of B vector, no? That is all.
Okay, okay.
Here. So I'll stop with this for today. So practice the problems which are based on this concept. You need some time to absorb it. So tomorrow I'll be completing the remaining parts related to lines. So tomorrow what we'll have is, since the crash course is also starting, tomorrow we'll have the class from 5 to 5:45. Okay. So if possible, if I get time, I will record and give you the content so that you can go through before the class. If not, I'll teach you. Is that point clear? So 5 to 6 we'll have this class. And 6 o'clock onward, the test series part will start. Clear, guys?
Yes, sir.
Any other doubt?
No, sir.
Okay, we'll wind up.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Sir? Sir?